Okay guys, in this video we're going to take a quick look at some of our factoring methods, specifically some of those that we've visited before on this graphic organizer. And so the main goal of today in large part is going to be able to factor a polynomial completely. And I suppose what we mean by that is just factor a polynomial down into its basic factors, at which point you couldn't factor them any further. And so we're going to be using a lot of the same techniques we've seen before, starting with just the fact that we always check for a GCF first. And so to recap what we've seen in the past, when it comes to factoring techniques here, we always check for our GCF first, and then we just kind of trace it out into three distinct kind of special patterns here. Patterns that have two terms, patterns that have three terms, let me fix this here, three terms, and then patterns that have four terms. And so in terms of factoring patterns, the ones we've seen before fall under our 2 and 3 term categories. One we've seen before is a difference of two squares, and that is our a squared minus b squared factoring pattern. And remember that anytime we have a squared plus b squared, this factors into a plus b, a minus b. If not a difference of two squares, it could possibly be a trinomial in quadratic form. And then for four terms here, the last one here, we're going to write down that we have a grouping method that we can put under here later. But for right now, we're going to stick to our 2-term and 3-term things, or binomial and trinomial things that you see here, checking for GCS first and trying to factor these completely. So from our assignment here, let's take a look at a couple. Starting with number 1 here. Number 1, I notice has 3 terms. If I'm going to factor completely, we're going to check for a GCF first. And so I notice that all 3 of these terms have an x in common. If we were to take out that x out in front, remember, this is the opposite of distribution. We're going to divide all of these terms in here by what we put out in front. So x cubed divided by x leaves an x squared. Negative 2x squared divided by an x leaves just a negative 2x, and then we here have a negative 24. And so at this point we would say, could I factor this further? Well, I notice that this has 3 terms, and so is a quadratic or a trinomial in quadratic form. And so because my a value is 1, I could think of two I guess things that multiply out to be negative 24 that have to be negative 2. And in this case, I suppose I could think of two numbers here. This would be a negative 6 and a positive 4. Would multiply out to be a negative 24, but add up to be a negative 2. And so this would be our completely factored form. And in large part, this is kind of what we're striding for today. So for instance here, if I were to look at number 2, I say, okay, well my GCF is a 4 and a k to the third. We could take that out. Dividing everything here by 4k to the third, I get left with just k squared in front. And this would be minus 25 and it would have no k's left. And so for instance, this here has 2 terms and is a difference of 2 squares. And so we could factor it out into what we call conjugate pairs here, where one's a plus and one's a minus. And we say, well, what's the square root of k squared? It's k. What's the square root of 25? It's 5. And then this here would be our completely factored form. So be checking for your GCF first, and then just look for any special factoring patterns after the fact. Cheers.